where do we find these weird negative roots? To start with, let us take one example. An equation such as x square plus 1 is equal to 0, or x square is equal to minus 1. Further, if you want to find the value of x, this is what we get. X is equal to under root minus 1. And then it is impossible to give the value of under root minus 1. At first glance, under root 4 and under root minus 4 may seem similar. They both involve the square root of 4. But they lead us down very different paths. Under root 4 is simple. It equals 2, because 2 square is equal to 4. But when we try to find under root minus 4, confusion strikes. Because no real number squared gives a minus 4. Because squaring any real number, be it positive or negative, always gives a positive result. It created a roadblock in mathematics for centuries, and hence the introduction of iota, that is equal to under root of minus 1. It is also called the imaginary unit. Imaginary unit or iota was introduced by Euler. Now let us play with this very interesting number called iota. Iota, that is equal to under root minus 1, can be written as simply I. And if we square iota, what do we get is simply the squaring of under root of minus 1. And the result is minus 1. If we do the cube of iota, then what we are doing is actually iota to the power 2 plus 1, that is iota square multiplied by iota. And since we got the value of iota square as minus 1, so simply we multiply minus 1 and iota, and our answer is minus iota. And then one of the most important results in imaginary numbers or complex numbers, that is iota to the power 4. That can be written simply as iota to the power 2 plus 2. That is iota square multiplied by iota square. And we know the value of iota square as minus 1. So minus 1 multiplied by minus 1, we get the value 1. Since we got the value of iota raised to the power 4, that is equal to 1, now it becomes very easy to find the value of any term like iota raised to the power any number, say it m. Let us take one example. So if we have to find the value of iota raised to the power 22, then the first step is simply divide 22 by 4. So 4 5s are 20, and the remainder is 2. Now we can write iota raised to the power 22 as iota raised to the power 4 multiplied by 5 plus 2. Or simply we can say that, write the power on iota as multiple of 4. Next step is separate the terms as iota raised to the power 4 multiplied by 5, and then this is whole multiplied to iota raised to the power 2. Now we know that iota raised to the power 4 is 1, so 1 to the power 5 and multiplied by iota square, that is minus 1. So the value is 1 into minus 1, that is negative 1. Now why don't you repeat this process as your homework and find out the value of iota raised to the power 27 and iota raised to the power 212. Let us define complex numbers. A complex number is an expression of the form x plus I into y, where x and y are real numbers, and I is equal to under root minus 1 is the imaginary unit. Complex numbers make the largest family. This family is denoted by capital letter C, or we can simply say that capital letter C represents the set of complex numbers. And we also have a notation for complex numbers. It is a small letter z, and this notation is just a convention universally accepted. there is no fixed rule, so you can also say that a is a complex number and a is equal to x plus iy, but simply we say that z is equal to x plus iy, which is a complex number. Now in this complex number, x is called the real part and y is called the imaginary part. And we write it as REZ is equal to x and IMZ is equal to y. That simply means real part of z is x and imaginary part of the complex number is y. And hence we can write z is equal to x plus iy, that is equal to real z plus iota multiplied by imaginary z. Also keep in mind that imaginary part of z is not iy. It is just y. So the real part of z is x and imaginary part of z is y. This very form, z is equal to real part of z plus iota multiplied by imaginary part of z, is the algebraic form of complex number. Or we can say the algebraic representation of a complex number. Algebraic representation of a complex number has other names, such as the standard representation of a complex number or the rectangular representation of a complex number. Let us take a couple of examples of a complex number. You can find something written as 2 plus iota or 2 plus iota multiplied by 5 by 9. In these two numbers, you can be asked to find the real part of iota and the imaginary part of iota. So let's take the first one, 2 plus iota. So 2 plus iota is actually 2 plus iota and multiplied by 1. So 2 is the real part and 1 is the imaginary part. Let's come to the other example. Here 2 is the real part and 5 by 9 is the imaginary part. Sometimes you will find numbers such as 5 plus under root minus 15. For such numbers, we have real part 5 and then imaginary part is hidden within under root minus 15. So if you expand under root minus 15 as under root minus 1 multiplied by 15, then you can write it as 5 plus under root minus 1 multiplied by under root 15. And then 5 plus under root minus 1 can be written as iota and then it can be multiplied to under root 15. And now it looks like a complex number where the real part of this number is 5 and the imaginary part of this number is under root 15. It is really interesting to know that any number you know or you don't know is a complex number. So any number can be written as a complex number. Take any number, be it 0. So 0 can be written as 0 plus iota multiplied by 0. Here the real part of 0 is 0, imaginary part of 0 is 0. So take number 5. 5 is a complex number. Here the number can be written as 5 plus iota multiplied by 0. The real part of this number called 5 is 5 and the imaginary part of this 5 is 0. Sometimes you will only see that numbers written as 3 iota. So here the real part is 0 and the imaginary part is 3. Or under root minus 2. Here the real part is 0 and the imaginary part is under root 2. Let us see these two examples once again. In these examples, if the real part of the complex number is 0, then the number 3 iota is called purely imaginary. And in the numbers such as 5, where the imaginary part of this number is 0, we call these kind of numbers purely real.